the compounds. All right, 5.2 is on naming. Very easy. We're not really going to make this too tough, but your benzene is your parent, so this is called bromobenzene. Very simple. If your benzene is the parent. We will see one case where benzene is not the parent, but most of the time benzene will be the parent. You don't have to say one bromobenzene, because it's just like on a cyclohexane, you don't have to say one if there's only one group on there. If you have like an ethyl group, all right, this would be called ethylbenzene. Okay, nothing too challenging. There are some common names for benzene compounds that have just historically been named this way, and I want you to memorize a few of them. One of them is a benzoic acid. This is benzoic acid. Benzoic acid. It's a very common compound. You can see it's a carboxylic acid with a benzene ring, so it's very simple, benzoic acid. Another one is toluene. Toluene, we've used that in lab. Toluene is the same as methylbenzene. Methylbenzene. All right, but that is a common name. Another one is phenol. That is if you have an OH hanging off your ring. This is called phenol, OL, because it's an alcohol. All right, these are just a few common ones. Another one is aniline. Aniline has a nitrogen on it, an NH2. That's aniline. So just a handful of common ones that I want you to memorize. Pretty much how you name them. So let's do this one, just to show you. So let's put a methyl here. So remember, this is a toluene. Okay, so this is a special case. So remember, this is called toluene. This CH3 aromatic is toluene. So that becomes your parent. Okay, and technically this is now your carbon 1 position. So if you go around, you'll see that this is 2, 3, 4, 5, 6. These groups are called nitro groups. So this is called 2, 4, 6, 6 trinitro-toluene. So I'm just kind of showing you how these common compounds are used. This is also known as TNT. This is the structure of TNT. Anytime you have these nitro groups on organic molecules, nitro groups on organic molecules are rather explosive. All right, they're very explosive compounds. They oxidize very easily. All right, so this is just to kind of show you how common names are used often. All right, let's talk about if you have a di-substituted aromatic ring. There are special names, di-substituted. Okay, so there's 3 types of possibilities. You can either have a 1,2 substitution. You can have a 1,3 substitution, or you can have a 1,4 substitution. Okay. Now there is a old nomenclature of how to name these. So if your groups are 1,2 substitution, this is called the ortho compound. Okay. So if you had chlorines, or like a bromine and a chlorine, let's say you had a bromine and a chlorine. So let's say a bromine and a chlorine. You name it alphabetically, just like how we've learned. However, you put ortho in front of the name. So ortho, bromo, chloro, benzene. Ortho, bromo, chloro, benzene. Or you can name it 1 bromo, 2 chloro, and this is because alphabetically, benzene. Okay? Instead of saying the word ortho, you can say O, and then bromo, chloro, benzene. All right, the O or the ortho implies it's 1,2. All right, the 1,3 is called the meta position. So you'd say meta bromochlorobenzene. all right, or M, or you use N, M-bromochlorobenzene. Finally, the 1,4 is called para, or P. You'd say P. So, like, let's do this. Let's do a toluene with a chlorine. All right. So, how you can name this is p-chlorotoluene, or parachlorotoluene. All right. So that's how you can name these. All right. What happens if you have more than one substitution, like 3 or 4? Same rules as with the cyclohexane. All right, you want to number the smallest. Your numbering system has to be the smallest numbering system. All right. So, and let's put in a CH3. Okay. So actually, let's put an ethyl here. CH2, CH3. We have an ethyl, a bromo, and a chloro. You want the lowest numbering system. All right. So with the lowest numbering system, it's basically going to be 1, 2, 3. So I'm either going to count it 1, 2, 3, all right, or I'm going to count it 1, 2, 3. Well, which direction? Either way, you get the same numbers. However, if you have a tie, you always go alphabetically first. So since chlorine, chloro, C, comes before E in ethyl group, this is the way I'm going to number it, 1, 2, 3. Okay, so the name of this would be 2-bromo, 1-chloro, 3-ethyl benzene. Okay, makes sense? Now, what happens when benzene is not the parent? Benzene not the parent. And when do you know? When does this occur? This occurs when the substituent hanging off of the benzene ring is too complicated to name it as an easy name. So like for example, let's say I have a benzene ring, and let's say I have something that looks like this. Okay? So notice my group hanging off of my benzene ring is not a real quick, it's not like an ethyl group. It's not a methyl group. It's not a chloro group. It's not a simple name. It's much more complicated. When that's the case, you go back to your alkane rules, all right, or your alkene rules, depending on what your longest continuous chain is. So notice this is my longest continuous chain now, excluding the aromatic ring. This is not a simple group to name. So this is now my parent chain. So my parent chain is this 1, 2, 3, 4, 5 carbon straight chain, and the aromatic ring now is a substituent, and the chlorine is a substituent. So when an aromatic ring is a substituent, it's called a phenyl group, or phenyl ring. So now you go back to your old rules, and this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Start on the end closest to the nearest substituent. So you have 3 chloro, 2 phenyl pentane. Okay? So that's when you use the aromatic ring as a substituent. It's no longer the parent. When the group hanging off of your aromatic ring is much more complicated, that's when you name it as a substituent.